In a typical materials recovery facility, a black plastic tray rides a black rubber conveyor belt at 3 meters per second. Near-infrared sorters look down, they see nothing. Carbon black absorbs the light before it reaches the polymer. The pneumatic ejector stays silent, the tray falls into landfill, 15% of the waste stream invisible. The failure here is not a software problem. It is not an algorithm waiting on a better prompt or a larger model. It is a sensor problem. Carbon black is a photon trap. A black object on a black belt under a near-infrared sensor returns a null signal, a data void. You cannot prompt a language model into seeing physics it never captured. The fix is upstream of the AI. Modern recyclers run near-infrared spectroscopy between 900 and 1700 nanometers. Tomra's auto-sort, Steinert's unisort, a halogen lamp illuminates the belt. Light enters clear plastic, bounces off the carbon-hydrogen bonds, returns a spectral fingerprint, but carbon black absorbs the incident radiation before it can reach the polymer matrix. The sensor sees a flat line, the robot perceives an empty belt. The wrapper response is to throw a larger language model at the noise, but generative models without input data hallucinate priors. Industrial sorting demands 99% purity at decisions under 20 milliseconds. Cloud round trips take hundreds of milliseconds. Guessing is not sensing. The solution is to shift the spectral window, move from near-infrared into the mid-wave infrared band, 2.7 to 5.3 micrometers. Carbon black's absorption coefficient falls off as wavelength increases. By the MWIR band, the pigment becomes sufficiently transparent that spectral analysis becomes possible. And this band carries fundamental molecular vibrations, CH stretches, C double bond O carbonyl stretches. Aromatic ring resonances, orders of magnitude stronger than the overtones that NIR sees. A black polypropylene tray that is a void in the near-infrared shows a distinct jagged spectral signature in the MWIR. The hardware to capture this signal is non-trivial. Veriprajna builds on the Specim FX50, the only commercial sensor covering the full MWIR window. The detector is indium antimonide, sometimes mercury-cadmium telluride. Both are exotic semiconductors that detect thermal radiation. To prevent the sensor from being blinded by its own internal heat, it must be cooled to 77 Kelvin by a Stirling cooler built into the camera body. The line scan output is 154 spectral bands per pixel across 640 spatial pixels at 380 Hz, a real-time hyperspectral data cube. Then comes the cognitive layer. The standard move is to push this cube into a 2D convolutional network, a ResNet or a YOLO. Wrong tool, spatial features fail in waste, a crushed bumper fragment looks identical to a torn food tray. The signal is spectral, so Veriprajna treats every pixel as a 1 by 154 vector and feeds it into a 1D convolutional neural network. Linear kernels slide along the spectrum, learning to detect a sharp drop at 3.4 micrometers, a broad shoulder at 4.0, a doublet peak, the grammar of molecular bonds. The compute math is unambiguous. 1D CNNs run in linear time, parallelize cleanly on GPS, and after TensorRT optimization deliver inference under 5 milliseconds on a Jetson AGX Orin. Transformers are quadratic. LSTMs are sequential, neither survives a 3 meter per second belt. Sensor fusion closes the loop. A low-cost RGB camera handles segmentation where the objects are. The FX50 handles classification, what they are. The PLC receives a single composite packet, object 452 black polypropylene position XY orientation theta. The airjet fires, the Delta robot picks. The economics are the proof. A mid-sized European MRF, 50,000 tons per year throughput. 5% black plastic, 2,500 tons. Current fate, incineration at a €100 per ton gate fee. Cost, €250,000 per year. With 90% recovery on a Veriprajna line, 2,250 tons sell at €900 per ton, just over €2 million in revenue, plus another €225,000 in avoided disposal. Total annual impact, €2.25 million. System capital cost, about $300,000. Payback under 2 months. Wrapper era is fragile by construction. If the underlying model provider ships your feature in their next release, your business evaporates, and no prompt can extract MWIR spectra model was never trained on. Deep tech is structurally different. Proprietary data, the spectral signatures of dirty, crushed, real-world waste do not exist on the public internet. Veriprajna generates and owns them. Physical moat, cryogenic detectors, edge inference. Mechanical integration with Tomra and Steinert sorters, not a coffee shop project. And by 2030, the European Packaging and Packaging Waste Regulation makes every package recyclable mandatory. If a sorter cannot see it, the law says it is not recyclable. Stop looking at the picture, start looking at the chemistry. The 17-page brief walks through the physics, the hardware, the model, the economics. We invite you to read it.